Welcome to this new tutorial of GraspR, and in this tutorial we're going to speak about complex visualizations that we can do and complementary visualizations that can be done in a very easy way with this application and can lead to some very interesting exploration of data. So in this case, our database is a weather database, a climate database that for different cities in the world have daily data for wind speed, pressure, temperature, dew point, visibility, cloud cover, etc. And so we have one value for each day. That value would be the mean value for the day. And with this data we can explore many things. It's a huge amount of data covering years from 2000 to 2014, and we are gonna make some complex visualizations using this application. So let's go. In this tree view we are gonna take the database with the data to make a reminder of how it is composed. We can see that we have all these columns here and a sample of unique values that we have here. And we are gonna, for example, in this case, let's explore the relationship between temperature, humidity, and pressure for different cities and for different months. So this is a relationship that we don't kind of know at the beginning, or perhaps somebody can try to explore that. And the key here would be to try to make some conclusions from the data that we didn't know when we began to explore. So now that we decided that we only wanted to have those three numeric variables like temperature, humidity, and pressure, let's filter the data and take only those things. So we will take all the cities that we have. We will take, let's take all the years for now, and we want the data by month, so let's take for each month, and we said we wanted temperature, humidity, and pressure. So we make the filtering. Let's check that that was correct. City, temperature, humidity, pressure, year, month. A sample of the data will be here. And if you want to display them in the web page here, we could display that. So let's do it to see the result of the first rows, of course, because this is a big one. So this would be a sample of the first 150 rows of the data we have made. Okay, so now we have the beginning of the data we want. So because we have all the years and because we have all the days for each month, we have a huge amount of data for each combination of city and month. So now we want to make an operation for these values that will make a mean, or the minimum or the maximum. Let's look for the mean value for all these years and all these months, for each month, sorry. So let's go here, take an operator, and choose split calls. So we don't want the years because the years is gonna be in the mean. So we are interested on city and month and on these three numerical variables. So we apply that. Let's check that we have the correct things. Split columns, we want city and month, and variable columns, we want temperature, humidity, and pressure. So this is correct. A sample of the data here would be, so for example, in Copenhagen, 1st January, we have these values. Okay, so now the data that we have are the mean values for temperature, humidity, and pressure by city and month. Okay, so now we can begin to visualize those data. One way of visualizing those data is to create, for example, a bubble chart. So a bubble chart is gonna be generated from this data, but we have to choose only one numeric variable. Bubble charts are charts that allow to see in a site, so visually and quickly, the qualitative behavior of a numeric variable that has a dependence in some categorical variables. So let's build one. Let's see the temperature. Let's see by city and month the temperature. So let's run that one and build the bubble chart here. So now we should have the bubble chart, and this bubble chart is showing now for the color is going to be assigned to the city in this case. And for each city we have 12 values, which are the values for each one of the months. So we have, for example, the value that I am putting my mouse on is Madrid, September, that is 20. So here we have already a visual and very quick and visual way to see this behavior of temperature for each one of the months. So in Moscow we have this very small one, which is a minus 8.1 in February, and perhaps in January is minus 8 point. We see that Dubai has always a big value, that Asuncion has always also a high temperature. Beijing oscillates a lot between very small, very low temperatures, minus 4.1, and the maximum, more or less, in August of 25.6. Copenhagen is also a city that oscillates a lot, but we see that Beijing is the more continental one, should be one of the more continental ones. That means that it should be, if you don't know which city it is, we could just say with this visualization that it's almost sure that we are talking about a city which is in a continental climate, because the oscillation of temperature between summer and winter is really huge. Same for Moscow, which has between minus 8 and plus 20. So many things that could be said for in this visualization, and also some things could be qualitatively discovered seeing this in a simple way, an intuitive way, and also in a beautiful way. So now let's go to some we talked about, we wanted to see the relationship between the variables. So not only the values, but also the relationship between humidity, pressure, and temperature. So for this, we are gonna use one of the most powerful visualizations that we have in this demo, which is the disk chart. So disk chart, it's a visualization that will take three variables that are numeric and one or two categorical variables, and will deploy a complex graph which has 5 different parts and that are also interactive. So let's go to the options panel and try to choose what do we want. So we have four variables that four characteristics that the plot has. It has an x-axis, it has a y-axis, it has a radius, and a color. Sorry. So let's take we want to see the relationship between temperature and humidity in this case, and we want that the radius is going to be the pressure and the color is going to be assigned for the city, for each city. So this is correct like in this way. Let's run the plot, let's check what we have. y is humidity, x is temperature, radius, pressure, color, city, and let's deploy it in the web page. So we generated one. So this first part, so this is a complex one, and it has this part here. It has also these two interactive graphs, and it has data deployed with the first 20 rows or 25 rows. So we can make many things with this graph, and let's explore the first one. So first, understanding what does it mean and how it is deployed. So we have a graph which has two axes, the temperature versus the humidity. So each point here corresponds to a relationship between temperature and humidity. For example, Beijing in this case has a temperature of 6.33, a humidity of 41.32, and a pressure of 1019.7. And it's in this case we are talking about Beijing, and we have a bubble which the size of the bubble corresponds to the pressure. So the smaller the radius is, the smaller the bubble is, the smaller the pressure is, and the highest the radius, the highest the pressure. So we see that Beijing has the maximum pressure around here, and Dubai seems to have a very low pressure also in these ones, but perhaps here inside we have other bubbles that have this. When we put the mouse on top of them, we can see the values here, and there is many things we can do here. So first, let's see some patterns. So temperature and humidity. For many cases, the temperature, this is mean temperature by month for all the years between 2000 and 2014 for each city. So we see that we have many of them that are covering between 5 degrees and 25 degrees and a humidity from 80 and 60. So this world here. We also see that there is a kind of a relationship which could be approximated by a linear line which would go in this way, following more or less these ones, these bubbles here, something similar to that one. So that's another thing that we can see. We can also see that there are some points in the graph that are outsiders, or that go outside the main ones. So we see that Dubai here it's a special one. So there's something is indicating that Dubai is a special place for the climate comparing for the others, and also Beijing here. Both of them are in the extreme of low humidity and temperature. So both have low humidity, and temperatures of Dubai are high and temperatures of Beijing are very low. And they have inverse relationship with the pressure. So the pressure here are very low and the pressure here are very high. So this is telling something, perhaps, that is telling that the pressure for the same humidity, when the temperature is high, the pressure tends to be low, and when the temperature is low, the pressure tends to be high. So this is one of the things we could see for low humidities. Madrid also has here, it's has the minimum humidity, and Copenhagen here has the maximum humidity. So that also indicates that Madrid and Copenhagen are very different in humidities, because Madrid is situated almost always here, So to explore by city, we could do something. We can come here to this second part of the graph and explore only, for example, for Madrid. So this is changing everything, changing the data, where we only see Madrid, changing the pressure histogram bars here, and changing the plot. So here we see a very beautiful relationship between humidity and temperature, which is almost linear going down. And the pressures here are also quite kind of very similar for each one of the months. So let's explore now more things about Dakar. Is also a city which is having a high humidity and high temperature and middle pressure. We could explore which are the data which have the minimum pressure. So minimum pressure is given by this one, which is Dubai, which has a temperature of 36, a humidity and a pressure of, this is the minimum one. This is for Dubai, and we can see it's the city is Dubai, temperature, humidity and pressure and those ones. Okay, let's reset this one and see also for Moscow. For Moscow we have very low temperature and high humidity. So each one of these cities have different relationships, and when we explore cities as Melbourne or Asunción, we see that they are much more uniform in their way of behaving. So they have a temperature, humidity and pressure which are much more constant than the other ones. Mexico City would be also an interesting one, which is appearing here now, and it's also making a bulk, and it's making some interesting also pattern. So let's explore now the same kind of graph, but taking different relationships. So let's go again to our application, GraspR, and now select another order. So now we saw temperature and humidity relationships. So let's go now for temperature and pressure, and taking the humidity as the radius, also for each city. So let's go there, make it run, and let's explore now this new data. So this new data is coming, is a very different one in reality. So it's the relationship between pressure, temperature and pressure now, instead of humidity. And here we have different ones. We see also that we have Dubai and Beijing, which are in the extremes of this, what could be also kind of a linear relationship, and almost all of them fall into that one. The minimum humidities that we have are for Madrid, as we saw before, and the maximum humidity come for Copenhagen, which is, so let's select Copenhagen and see how it behaves. So Copenhagen has a high humidity, because we could see here the histograms of it compared with all of them. Copenhagen is really situated in the high humidity, it's always humid, and temperature is going between 0 and 20 degrees. If we compare Copenhagen with Mexico City, for example, we see that they really belong to a different pattern, and they don't touch. Humidity in Mexico is lower, pressure is higher, and temperature are also higher in general. Let's add Madrid and see how Madrid is a little bit similar to and follows a relationship like that, but the humidity in Madrid varies a lot. Perhaps we could have the same in other continental ones. So this allows the comprehension and the understanding of some of the characteristics of cities and makes us able to explore in this easy way different complicated relationships. Let's add another one. Let's add another one with the same data, but now we are going to try to see other things. So now we have the relationship between pressure and temperature here. We have humidity and temperature, and now we want pressure and temperature. So pressure and humidity. Okay, so let's make the graph and see what we can discover with that. So now we have another graph which is humidity versus pressure. Before we had temperature, pressure, and we had temperature, humidity. So now the disk radius are the temperature, and here we can see other things. Also Dubai is, Mexico is a little bit here, Beijing is more inside, and Madrid is there. So let's, for example, take Asunción, and we see that the temperature of Asunción are high, and the pressure are also high in comparison with Beijing. Beijing oscillates between all these, so let's take Beijing as, so it's the big oscillation between them. So here we can see the values and we can explore temperatures, maximum temperatures, minimum temperature, etc. So this is a way to see complex relationship between variables with this single but very powerful visualization, which is the disk chart. Same data can be visualized with others, like hierarchical bars. We could deploy hierarchical bars are, let's see, for example, humidity by city and month. So hierarchical bars allow to see the aggregation of the data and order it by values. And here we have, for example, we are talking about humidity values by city and month. So we have the city, and here is the accumulation, the sum of the values for each month. So it's 12 sums here. Dubai is the last one. If we click here, we will see for each month which is the value, and we can see the value, the exact value here. And here we deploy also that. So this is also a way to see it, but of course, to see the relationship between variables, we can discover them much easier here and make some exploration with the mouse and compare two values or three values, have here the precise data, and this could be a very useful tool to look for patterns or look for differences in data. So this is it for this. Remind you that you can save this configuration and let's save it as disk chart example. And if we do that, when we open and we load that, we will have this disposition, and we can run them with the options that are already selected, and see in the web page the results. All these results are kept in the web page and can make a very interesting document, and here we can access each one of the things we have done. And so this is it, and I hope you like this tutorial.